Hello, and thanks for watching. My name is Oscar Rodriguez, and our project is the Smart Showerhead. Many people invest a lot of money in their houses, and one of the most important rooms in their house, besides the kitchen, is the bathroom. Everybody needs it, right? Everybody uses it, right? That is why many people like to buy shower heads that have different modes and settings. How many of you have one of these shower heads at home? Now, how many of you really take advantage of it? Very few of us. Personally, I can tell that I hate going up there and change the modes manually. And that is when we come in. We are designing the most innovative and creative smart shower head. And this is why we consider that our smart shower head is going to revolutionize the industry. Our shower head is going to have customizable water temperatures, 4 user temperature modes or memories, 2 different water modes that are going to change automatically, wireless control remote to communicate between the shower head and the shower console, an auto power generator using energy harvesting devices.
Our area of focus is microcontrollers, electronics, and computer-aided design. Microcontrollers are versatile and they can be easily integrated into our system. Electronics can be used to cover any sort of gaps that we might have after everything's done with the microcontroller. And computer-aided design will help us in designing the mechanical aspects of the system as well as the enclosure.
Here's a block diagram for our system. As you can see, I color-coded it to highlight each component to tell which system it's being used for. So I can start with the power system. We're going to have a battery charging integrated circuit that charges 2 lithium-ion battery packs, and the hydroelectric generators charge the charger, as well as 2 AA batteries for the stepper motor for the shower head, 2 AA batteries for the remote control and the stepper motor on the faucet. And this makes 3 different places with replaceable batteries. Our team would really like to get rid of the 2 AA batteries that go with the stepper motor, but that's always an option if we can do that. For the green, we have the LED warning and pause system, which is just an LED array connected directly to the MCU. The temperature sensor obviously also is in there, but it's blue for temperature control. So the green ones also has the latching solenoid, which barely uses any power. We use 2 different power amps to reverse polarity when we need it to open or close. In purple, we have the usage logging system, which is just the Bluetooth sensor and the flow meter. Light blue is the user interface, which includes the remote control and the LCD touchscreen. Dark blue is the temperature control, which includes the shower faucet, an RF transceiver, stepper motor to turn the faucet, and the temperature sensor that's connected to the MCU. In orange, we have the mode control system, which is just the stepper motor. All the stepper motors we have their own driver that comes with the motor that we'll be using as a connection from the MCU, or in the case of the faucet, from the RF transceiver. And multiple systems here using, obviously the MCU is used in most, if not all, of the systems, and the shower head is just used in the few here that you see connected to it. Our smart shower system will be designed with these key features in mind. Number one, it will be user installable. This will set us apart from our competition, as most of the competitors of the smart shower system have complex installation that goes inside a wall and would normally be installed by a technician. Number two, we want to digitally control the temperature. We can do this by placing a stepper motor over a single faucet shower system. Number three, we want to digitally control the shower mode, and we do this by putting a stepper motor over an existing shower head. And after we have that down and working, we're going to try to add in replaceable parts to make it universal. Number four, we want to incorporate sensors to log water usage and send to the user via a cell phone app. We're doing this with our Bluetooth communication and using the flow meter to log how much water is used in each shower and what times of the day. We want to use a in-shower touchscreen for our user interface. In order to do this, we just have to work on creating a water-resistant encasement for the control box microprocessor and Bluetooth, things like that, and the touchscreen is going to go on top of the control box. Number six, we want to have a remote control. It's really self-explanatory. Customizable presettings, again, that's all just coding the microcontroller correctly to respond to the remote control and to the touchscreen user interface. We're going to utilize hydroelectric power to reduce user maintenance, which is replacing the batteries. We would like to have only 2 replaceable battery sets in the entire system. One would be for the remote control, and then another either for the solenoid that controls pausing the water or for the stepper motor that changes the mode on the shower and the temperature. Hopefully just the temperature. That would be where we want it to be. Number 9, we're incorporating an LED warning system for low hot water supply, as well as to alarm the user when the shower is ready. Also included in this feature would be the solenoid to pause the water flow once it reaches the appropriate temperature. This slide is a water flow path diagram. It just shows you the path of your hot water through your shower. This is basically just to show you the order that we will have everything set up, and all these components are integrated into a 1/2-inch pipe already, besides the temperature sensor, which we would have to drill a hole into a section of 1/2-inch pipe, put the temperature sensor into it, and have it hang out the edge, stick the temperature sensor into the water supply, and then screw in our section of pipe. And obviously we would have to seal up the hole with plumbing epoxy. So from your water supply, goes through the temperature sensor, through the flow meter, then through 2 hydroelectric generators, through our latching solenoid to pause it, and then right out the shower head. So these are the only components that will come in contact with the water, and they are mostly, besides the temperature sensor, they are all already designed to work with running water.
In our design, these are going to be the main components: waterproof temperature sensor, a hot water flow sensor, a portable water charger, a latching solenoid, a rear ran stepper motor, a wireless antenna, a touch screen interface, the MCU at Mega 328P, a lithium battery, and a Bluetooth module BLE113. As far as requirements, from the user, the maintenance required is minimal, due to the fact that the few things that the user needs to do is to replace the batteries and also link his phone to the application that we're going to create that is going to manage the smart shower head from their devices. From the system, there are a few requirements that need to be met. First, the microcontroller power supply needs to be necessary for it to work properly. The pressure range of 8 psi to 60 psi needs to be there for the scavenging mechanism to work properly. The batteries need to provide enough voltage for the solenoid and the touch screen. We also need to create specific adapters that will complete the connection with the modern shower valves. And lastly, we need to make sure the insulation for the system is going to be the most appropriate.
Here's our current timeline. It focuses on tasks we've done this semester as well as what we're going to be doing next semester. The group's tasks are divided up between 2 people so that we have ample coverage. At the moment, we're currently focusing on preparing for the CDR in January. From then, we're going to focus on programming and component integration, and then finally, we're going to do the system integration as a group.
I will speak now about the technical risk of our project. The first one is the power budget. Our main idea was to use one hydroelectric generator to power up our main components, but after several tests we find out that this is going to be almost impossible. So we decided to use a rechargeable battery for our main stem motor, and then to use a second rechargeable battery for our solenoid valve and for our microprocessor. This second rechargeable battery is going to be connected to 2 or more hydroelectric generators. Our second issue right now is the insulation. Right now we are in the phase of testing every single component, and then we're going to put our whole system together. And if everything works perfectly, we're going to start worrying about insulation. Due to the fact that we're dealing with water, we have to insulate most of our components. This will take space and money. Also, we're thinking to put a little step motor inside our shower head to rotate it. So we have to take in consideration leakage coming out from there. We are thinking right now to use some plumbing sealing to stop that leakage. Market. Our targeting market will be people with disability, particularly in the legs. Our product will be connected through a wireless control, so these people can enjoy all the features of a shower with a touch of a button. Also, we are shooting for water industries and customers who worry about the water bill. They can get feedback from our systems, such as duration of the shower and water consumption. And our main targeting market are the middle class people. We are trying our best for our system to be in an affordable price range. Okay, now the risk of our whole project. We need a huge budget for advertisement. We need to find retail that want to sell our project or product. We need to find business partners that want to invest in our product, and we have to overthrow similar business. And right now this table over here is about our competition. You can see the similarity and difference between our product and our competition that right now is in the market. We have the same digital display, we have the temperature control. We are not going to use a pressure control because this consumes a lot power, and we are trying to avoid that. But the difference from our product and our competition is that we're going to have a rotation of the shower head We're going to have some feedback water consumption. We're going to have LED in the top of the shower head, and of course the main one is our price. And the course that are key to our design going to be, we are going to implement an RF transmitter and receiver, and our classes of wireless and communication system going to be of great use. We're going to do a reverse engineering of the shower head. So on our engineering design class will be of great help too. Our hydroelectric generator or power budget and our test motor can be related to our electromechanical system, or the two VGT that we have to use can be related to our semiconductor and to our electronic one class, and our microprocessor can be related to our microprocessor class, to our microprocessor lab, and to our coding class.
We are designing an affordable system to create an optimal shower experience. Modern design using a touchscreen interface, energy harvesting components with a power rotating shower head. We are ensure our product will change the way you shower.